Look at this image of Earth. To us, this floating blue sphere feels infinite. It holds every person you've ever known, every story ever told, and the entire sum of human history. But our brains are biologically biased by our earthly surroundings. We aren't built to comprehend true cosmic scale. Down here, driving a car at 100 kilometers per hour feels fast. It is a velocity we intuitively understand. This diagram shows what happens when we apply that familiar highway speed to space. To reach our closest neighbor, the Moon, you would have to drive at a constant 100 kilometers per hour for over 160 days without stopping. This staggering gap exists just between Earth and its own local satellite. It is the shortest leap we can take, yet it reveals an expanse so vast it breaks our everyday sense of distance. When we finally cross that gap, the view looking back is sobering. Standing on this barren, cratered surface and looking into the black sky, our supposedly infinite world is reframed into a fragile, finite speck, isolated in the dark, and we haven't even left our own backyard. To measure the rest of our solar system, we have to use the speed of a commercial jet flying at 900 kilometers per hour. Even at that speed, a trip to the sun, roughly 150 million kilometers away, requires a relentless 19-year flight. Because planetary orbits constantly shift, these gaps wildly fluctuate. Aiming that same commercial jet at Mars when it is on the opposite side of the sun would result in a flight lasting upwards of 50 years. This photograph captures Neptune, the ice giant marking the outer boundary of our planetary neighborhood. It sits 4.5 billion kilometers from Earth, a distance so extreme that sunlight takes over 4 hours just to reach it. Only one physical object has pushed past these planetary boundaries. The Voyager 1 space probe, launched in 1977, has traveled for over 4 decades to reach 22 billion kilometers, becoming humanity's farthest physical emissary. In 1990, when Voyager was about 6 billion kilometers away, it turned its camera backward for one final look at home. As the astronomer Carl Sagan observed, that resulting image reduced our entire world to a mere pale blue dot against the void, forever resetting our perspective of planetary importance. Once we leave the solar system and enter the wider Milky Way, kilometers become useless. Astronomers instead measure space using the light year, the distance light travels in 1 Earth year. This diagram shows our home galaxy, spanning 100,000 light years. The highlighted section is the human radio bubble. Extending 100 light years, it marks the limit of our broadcast history. Outside this microscopic sphere, the galaxy is entirely oblivious to our existence. Our radio and television signals simply haven't had enough time to reach them yet. Humanity's entire recorded history and global presence is functionally a whisper that hasn't even crossed our own cosmic backyard. Leaving the Milky Way for the vastness of intergalactic space reveals the local group, a cluster of over 50 galaxies spanning roughly 10 million light-years. But even that group is a minor neighborhood within the Virgo supercluster, a collection containing thousands of galaxies and stretching for over 110 million light-years. This structural map shows an even grander scale, the Laniakea supercluster. Extending over 500 million light-years, this web holds the mass of 100 million billion suns, bound by immense gravitational flow. Look closely at this structure to find the Virgo supercluster, the local group, and our entire Milky Way. They are all contained in that single microscopic dot. At this scale, our massive galaxy, with its billions of stars, is reduced to a single pale blue dot against the sprawling backdrop of Laniakea. Pushing to the absolute boundary of our vision, we hit the limits of the observable universe, an expanse stretching roughly 93 billion light-years in diameter. This creates a chronological paradox. If the universe itself is only 13.8 billion years old, how can the distance across it measure 93 billion light-years? The answer lies in cosmic expansion. Since the Big Bang, the physical fabric of space between celestial bodies has been stretching, actively driving galaxies apart and increasing the total volume of the universe. Because space itself is stretching, the most distant regions are now moving away from us faster than the speed of light. Their light will never reach our telescopes, permanently sealing them off from human view. We are adrift in a potentially infinite universe that is aggressively expanding away from us. This deep isolation, surrounded by an endless and unreachable void, means this fragile blue speck is our only harbor. It is infinitely precious.